Every line of code you have ever written cannot interact with hardware directly. It can't write to disk, can't open a network connection, and can't even ask the clock what time it is, not on its own. The hardware is completely off limits, and that's by design and not an accident. Today, we are going to understand exactly why that wall exists and the one mechanism that lets your code cross this boundary. Your program lives in what's called a user space. Your application code, the language runtime, the standard library, all of it runs here in an unprivileged execution environment. On the other side is kernel space. This is where the OS lives, the scheduler, the memory manager, the file system, and the network stack. Code running here has full hardware access, and the wall between them is not a software convention, but it is enforced at the CPU level through hardware privilege levels. User space code physically cannot execute the instructions that kernel space code can. So, how does your code ever get anything done? The answer is through a system call, the one legal controlled path from user space into the kernel. A system call is not a regular function call. When you call a function, execution stays in user space. A system call crosses a privilege boundary. The CPU changes its execution mode. And the critical point is that kernel decides whether to fulfill the request. Arguments are validated, permissions are checked, and the kernel is not obligated to say yes. Let's walk through what actually happens. First, the arguments and the system call number are loaded into specific CPU registers. Then, the system call instruction executes. This fires a software trap. It's similar to a hardware interrupt, but triggered by software. The CPU switches from user mode to kernel mode. The kernel takes over. It looks up the system call number in the system call table and calls the corresponding handler function. The handler runs the operation with full hardware access, and when it is done, the return value is written back to a register, the CPU switches back to user mode, and your program resumes exactly where it left off right after the system call instruction. How does the kernel know which function to call? Through the system call table, an indexed array of function pointers. The system call number is just an index into that table. Number 0 maps to read, number 1 maps to write, number 2 maps to open, and so on. On a typical Linux system, there are roughly 350 entries in this table. The kernel looks at the number in the CPU register, calls the function at that index, and that's it. It is just a simple table lookup. System calls fall into few categories based on what resources they operate on. Process control, fork, exec, exit, wait, etc. for creating, replacing, and managing processes. File I/O, open, read, write, close. Every file operation goes through here. Memory, mmap, and brk are how the heap grows and how file gets mapped into address space. Network, socket, bind, connect, send. Every network connection is a system call. Inter-process communication, IPC, pipes, shared memory, semaphores, and time. Clock, get time, nanosleep. Even checking the clock requires asking the kernel. System calls are not free. Every system call requires a mode switch. The CPU has to save register state, validate arguments, and change privilege level. That's unavoidable overhead. And switching into kernel mode can also flush TLB entries and pollute CPU cache. So there is a cold start penalty when you return to user space. How much does this cost? A single system call is roughly 100 to 1000 nanosecond, while a regular function call is around 1 nanosecond. That's an order of magnitude difference. This is exactly why stdio buffers write. If you call write once per byte, you would be making one system call per byte. Instead, stdio accumulates data in a user space buffer and flushes it in a single write call. Buffering exists entirely to reduce system call frequency. That's it for today's video. I hope you now understand all about system calls. If yes, then please do like this video and comment down if you have any questions or if you want me to cover any other topic. Subscribe for more such content. See you in the next one.